Welcome to Known Unknowns. In 2021, China's Chang 5 mission returned to Earth with lunar samples. As scientists from the Institute of Geology and Geophysics of the Chinese Academy of Sciences studied the samples, they noted that prior lunar missions such as Apollo and Lunar recovered samples older than 3 billion years. As such, scientists initially believed that the Moon was geologically dead since then, according to a study published Friday in Science Advances. Chang 5's samples challenged that theory about Earth's only natural satellite. Led by Professor Yi Chen, the researchers reported that the samples contained signs of volcanic activity that was only 2 billion years old, the youngest lunar volcanic rocks to date. Upon further study, the researchers found that mantle melting point depression caused by the presence of fusible, easily melted components could generate young lunar volcanism. The scientists first hypothesized that either elevated water content or heat-producing elements in the lunar interior drove volcanism in the late state of the Moon's life. However, Chang 5's samples disproved these theories, scientists revealed in 2 articles published in the journal Nature in 2021. Dr. Bin Su, first author of the study, believes the location provides one explanation. The selected landing site of the Chang 5 targeted potentially some of the youngest lunar volcanic regions, Su said. The researchers used crater counting chronology, an estimate of the age of a planet's surface by the various sizes of impact craters, to predict that the lava flows at the Chang 5 landing site are much younger than the basalts collected by the Apollo and Lunar missions. After comparing 27 precious Chang 5 basalt clasts to Apollo basalts, the researchers found the Chang 5 source magma contained greater calcium oxide and titanium dioxide content than the Apollo magmas. Per the study, the late-stage lunar magma ocean cumulates are rich in calcium, titanium and more easily melt than early cumulates. Because of this, the fusible components possibly join the lunar interior through gravitationally driven mantle overturn. Also, the researchers found that the Chang 5 magma was 176 degrees Fahrenheit cooler than older Apollo magmas. This means that the lunar mantle experienced sustained, slow cooling to that temperature between 3 billion years to 2 billion years ago, and that the fusible components joining the lunar interior reduced the mantle melting temperature and triggered the young lunar volcanism. This is a fascinating result, indicating a significant contribution of late-stage lunar magma ocean cumulates to the Chang 5 volcanic formation, said Dr. Su Bin. This work presents evidence for the first viable mechanism to account for young volcanism on the Moon that is compatible with the newly returned Chang 5 samples. This study can help planetary scientists better understand T.